How standards can simplify the connection within your factory. IPC-Hermes and IPC-CFX are our topics for the day. My name is Haytham Jaridi and I welcome you in the show.
Welcome to the Facts on Open Automation show of ASMPT. Do you know that 11,000 tons of unused chargers are produced annually, and yet people spend 2.4 billion euros in the same amount of time? Well, to reduce that and to make the life easier of everybody, you as a consumer and you as an electronic manufacturer, the European Union recommended a standard on electronic chargers. And of course, you are asking yourselves, what does this story have to do with open automation? Well, that's what I'm going to discuss with two of my guests, Haytham Jaridi and Johannes Lettenbauer. Hello.
Hi, Laszlo.
Hello, Laszlo.
Haytham, does our equipment need now USB-C chargers?
In fact, we need standards, so maybe not a direct USB stick, but in fact we have different dedicated equipments within the production, within the shop floor, different systems. And the question is, of course, how to connect all of them together. So we're talking about interfacing these equipments to each other. And for sure, we require standards to simplify the connection between all of these equipments to achieve integrated smart factory.
So connectivity is important here for open automation. Connected manufacturing is necessary to avoid waste and to avoid downtimes.
Absolutely. And even some statisticals are showing us the next couple of years which importance providing data and handling data and using data, of course, will have a big impact on the production itself. So as you see, for example, for the next couple of 5 years, the importance of having data to provide predictive maintenance, for example, or even connected planning or any kind of big data driven processes are very important, and how I can then provide this kind of data if I will have different systems and different interfaces. So it's very important, of course, to standardize kind of these interfaces together.
Perfect. So what does ASMPT offer in this regard?
Actually, we have thought about interfacing a long time ago. So the connection itself by the machine or systems to any third-party equipments can be provided by specific interfaces. But if it comes to standardize the interface itself, ASMPT already is leaning on IPC-Hermes, for example, as a vertical communication. So we're talking about equipments which can talk to each other in a line. But also if it comes to upload the data to a high-level systems like any factory-level systems, then it's also very important to also stick here on standards like we do with IPC-CFX.
Johannes, Haytham mentioned IPC many times. Who is IPC?
So basically, IPC is a business initiative that aims to simplify and also standardize machine-to-machine, but also machine-to-business communication solutions with a global standard. So in this regard, we can, for example, have machine communication inside of one line. So on a horizontal level, meaning we do have got a machine-to-machine interface using the IPC-Hermes, but maybe also the vertical level and the communication of the entire line with an upper level system, just like an MES or maybe an ERP system, which can be achieved with the IPC-CFX standard.
So good, IPC helps that everybody speaks the same language.
Exactly.
Let's see in our next feature what IPC-Hermes and IPC-CFX does.
Standards are made to simplify the connections between machines and systems. We talked about IPC-Hermes, which can provide data. So we're talking about a piece of information which can be here, of course, added on top of the board availability, will be generated at the beginning of the line and can be then forwarded to the next machines. So let me, for example, start with the existing example, which is the barcode information itself. So as soon as I have a top or barcode or bottom barcode in my TCP/IP protocol at the beginning, generated by one of the machines in the line, I can, of course, skip all of these barcode reader within the line, since I have identified the board one time, and then I can provide or communicate this piece of information to the next equipments by a TCP/IP Ethernet connection to the next equipment. So let me have a look also here in our line. We are, by the way, in our COC demo center in Munich with a complete IPC-Hermes line. And we started already here also providing all of this information which each single process machine needs, provided by a single IPC protocol here generated at the beginning of the line. So what happened here is actually we're generating the TCP IP protocol based on the barcode which is sticked on the magazine of the PCBs. The loader then can read this barcode, generate a complete protocol on Hermes, put in also the, for example, product type ID, which is an identifier also for the product of these PCBs, and then provide this piece of software or of information from the loader to the printer and so on. As soon as I can then provide this information to the printer can then use this kind of information. So we're talking here about reading the protocol itself, figuring out, oh, okay, there is now a product type ID included in this IPC-Hermes protocol, and use this piece of information to ask a programming tool, which printing program do I have for this product type ID? And the printer just did it now and downloaded the right printing program based on this product type ID provided from the NUTEC loader. I only need here to confirm for the setups, and then the printer can continue first producing the board and then communicating these kind of informations to the next available equipments within the line. Talking about SPI, for example, or placement machines, or even AOIs, which are capable, by the way, in our lines here, the one AOI from Viscom and our machines, to read this information and then download the job automatically. Now, if it comes to the small equipment such as conveyors or shuttles within the line, of course, a piece of information, which is the width of the board, can be relevant. So I don't need to go to the shuttle or the conveyor to set the width of the board. This piece of information can be also generated at the beginning based on the barcode or the RFID I have triggered to the loader, and then call all of these needed information such as length or width, and each single conveyor here in our line or board handling equipments will then set automatically the conveyor width based on this piece of information. So actually we're talking about a very simple communication between all of these equipments, not only based on the signals, but on XML files or TCP IP protocol, which includes a lot of information. And then I can skip all of these kind of, let me say, specific connectors of SMEMA, which you might have today, which are also cost-driven, but also save the time to set any dedicated conveyor with, for example, based on one standard, which we called IPC-Hermes. A simple line communication will help me a lot to avoid a lot of manual works here. On top of this, of course, we mentioned also IPC-CFX. You can imagine there is more information in the line which can be communicated in a vertical way, means NES systems, for example, or EIP systems, any kind of IoT platforms which needs information from the lines itself for interlocking or any production or material information, can be then also provided not on the horizontal communication but on the vertical communication through a standard which is IPC-CFX. If you'd like to see more about such kind of use cases using standards, don't hesitate to visit us in our demo center for the remote sessions even. And of course, don't miss any of our remote sessions which are available on our platform.
So you see, open standards like IPC-Hermes helps to reduce waste, costs less, helps to achieve a better quality, and makes the life of everybody easier. Johannes, some viewers may ask, what is the difference between the old standards SMEMA and IPC-Hermes?
So well, Laszlo, so first of all, IPC-Hermes is a vendor-independent, state-of-the-art machine-to-machine communication protocol, which is based on TCP IP and is overcoming some of the limitations the current SMEMA standard has, and by doing so is offering a variety of benefits in comparison to its predecessor. So let me start at the beginning. So both standards are basically supporting the PCB handover from machine to machine. But the IPC-Hermes standard is doing it on a protocol base, and the IPC-SMEMA standard is doing it on a signal basis, and is thereby using a variety of electrical cables. So for the SMEMA standard, it's always necessary to read the barcode for each single machine in the line before the conveyor width can be adjusted. So now with the IPC-Hermes standard, it is possible to only have one board identification at the beginning of the line, and the process relevant data will be directly transferred to all other machines in the line. So for example, then the machine can automatically adjust its conveyor width, and all of the relevant data are saved in a protocol.
Perfect. So I see I already have less of hardware costs. The question is, how much does it cost to implement Hermes?
So in principle, the use of IPC-Hermes is free of charge for any vendors, for any suppliers, by the initiative itself. But of course, it is important to mention that for some of the features for dedicated machines, or maybe for some kind of special vendors or customized applications, there might be a customized fee required.
Good. Then in this regard, some of the viewers may ask, what is the return of investment of Hermes?
Laszlo, we're talking now about data which we can provide from the one equipment to the next. So actually we can save any additional hardware, for example, such kind of a barcode reader. So as Johannes mentioned, we can read the barcode at the beginning and provide this via Hermes. So any additional barcode reader is cost we can save. Next to it, of course, all of the interventions done by the operator to, for example, set the adjustment of the equipment itself, we can also save, which is also, by the way, time. And time is, of course, money for the production line. Next to many, many other features, vendors can implement to achieve a very nice return on investment just by implementing a standard.
Speaking of features also, very good point. So does it mean if any vendor, any equipment supplier has Hermes on board, they provide the same features and options?
That's a very good question, actually. We're talking about a standard and an interface. Means Hermes is not providing any features in this term. It's only providing data which can be added based on the equipment itself. So it starts with a dedicated information like the board ID, maybe a barcode reader can put in a barcode information in it. All of the additional features for the conveyor adjustment or even auto job download, all of these kind of functionalities which we can only do based on the Hermes protocol are, of course, an additional implementation by the vendors and suppliers itself. So if it comes to the features, of course, it's a job the implementer need to do, but thanks to the existing interface, which is IPC-Hermes.
Good. Now, not everybody has a shiny new production. Some of the users have old equipment, legacy equipment, or customized equipment. What shall I do if I have an equipment which does not deliver data?
Yeah, as Johannes mentioned at the beginning, of course, the prerequisite to be supporting Hermes is the TCP IP connection. Means it's a protocol which can be provided by a TCP IP. Means any PLC within the line should be capable to provide an Ethernet connection to the next equipment to be capable to provide an IPC protocol. However, of course, these may be old equipments which are not capable to be upgraded to support such kind of connections. These today, of course, existing solutions to overbridge such kind of non-Hermes equipments to even achieve a Hermes line without having Hermes equipments within the line. Means we can implement, for example, a ZIG box in front of non-Hermes equipments and overbridge and convert the Hermes to SMEMA and then back from SMEMA to Hermes again to just overbridge any non-Hermes equipments within the line. And at the end, of course, we can achieve any Hermes lines even without having Hermes equipments in it.
Perfect, thanks. Also, Alessandro Bonara from our last show has legacy equipment in his production, and he's interested in more than just tracing the data. Hello, Alessandro. I'm happy to be here again.
Hi, Laszlo.
You are using Hermes SMEMA Connect from the company SIG. Why? What was the problem?
As we discussed last time, we started the operation in 2012. and since then, we changed a couple of equipment within the production with the new equipment, but not all of them. So they are known every equipment inside, especially in the line. We still have some old equipment, and is now still using the SMEMA connection possibility. And this way, we have three kinds of possibility. One possibility is to change with a new equipment, and there will be a cost question. The second point is also update the electronic inside and the computer and the controlling. And the third point, this can be using a solution that's very easy to install and very, very adaptable. And this is a solution from the company SICK.
So a very easy solution. So what are all the benefits at the end for you?
Okay, besides the benefit that we have within the line, that all information is coming in. But the benefit, first of all, that actually costing, that's very easy to install and easy to adapt in our solution. But one of the third points that we are working now and we want to increase is the intralogistic possibility.
Intralogistics, that sounds very important. What is intralogistics?
You have a different working island, like call it like this, inside the production. And now within the line, you have an M2M communication system to the Hermes. But we can also use this one to move this information from one working island to the next working island. Of course, we're using something else, MES system, but we'll discuss it maybe in the next show. And we can use the same information that we get out of the line and move this information to the next step. This meaning we have a control information within the production line and traceability.
Well, perfect. Intralogistics, that sounds very important. We will cover that in one of the next shows. Thanks, Alice.
I will be happy about that. Thank you very much.
Hermes SMEMA Connect from SICK, a possible solution for you. A general question to you, Haitham. Does it mean if anybody, any vendor has Hermes on board, it's easy to connect to any line?
Absolutely. So the only prerequisite is, of course, to support Hermes, which is an open standard interface. Yes.
Perfect. Johannes, how does a Hermes solution look on our ASM placement equipment?
So as already touched on earlier before, we do have got a wide range of applications implemented based on the IPC-Hermes standard, and that are also available inside of the communication protocol that comes with the IPC-Hermes standard. So just only to mention a few of them, we do have got the whispering down the line of fiducials or barcodes, also the automatic job download. But maybe, Laszlo, before I talk too much here, let me explain our features for our SIPLACE placement machines and also our latest innovations in terms of automation for our SIPLACE placement machines in a short clip. So each machine here in our line receives always an upline Hermes message, and based on that information, our SIPLACE placement machines can then adjust the conveyor width accordingly in advance before the transport of the PCB itself. The second major use case of the IPC-Hermes standard is the automatic job download. So based on the standard protocol, the SIPLACE placement machines automatically knows which program to use and can then ask our ASM Works to provide the next recipe to it. This can then be downloaded and the production can start automatically without any need for operator intervention. A third major benefit of the IPC-Hermes use is the whispering down the line functionalities. This has the big benefit that these fiducials only need to be read once at the very beginning, and then all of the information can be traced to the complete downward machines. This saves a lot of cost and also increases the machine availability. Last but not least, the fourth major use case I would like to point out today is the transfer from a single lane to a dual lane. So as we see in many factories, we have, for example, a printer or a solder paste inspection machine running in single lane, and then we do have got a SIPLACE placement machine, which is normally running in dual lane to achieve the maximum throughput for the line. Normally, a shuttle in between is required to transfer the board from one lane to the other one. In this case, there are two main deficits that the standard process has. So one would be the additional use of barcode scanners, or the second one would be the loss of accuracy of traceability data. With IPC-Hermes, you now have the possibility to create a board message with the barcode information and can then trace the complete information also when moving from a single lane to a dual lane. So that already sums up all the main benefits for the IPC-Hermes standard. And let's not forget our latest and new innovations for our SIPLACE placement portfolio. And therefore, let's hop over to our second line. I would like to show you now our latest innovation for tray feeding solutions. With the SIPLACE tray unit here, we do have got a flexible and automated way of feeding any kind of trays inside of a very compact design without any additional floor space in front of the machine. So the SIPLACE tray unit is generally being based on 3 different modules. We do have got the cage module on top with up to 12 levels of trays. So these are basically the levels of trays that are being used during production. And this ensures us to have here a refill unit to automatically and non-stop refill any kind of trays during production and have no stoppages in the line. At the very bottom, we then do have got the main storage where we do have got the possibility to store up to 30 different levels of trays. When we now have a closer look at one of the trays, we can directly see each level of tray has the space to cover up to 2 JEDEC trays next to each other. Secondly, we do have got now a new feature implemented for all levels of trays, which is now here on the right-hand side, our RFID tag. With this RFID tag, we have the chance to trace the level of trays throughout the complete process when it is moving from one module to the other module inside of the machine. The second big benefit of this is that now, together with ASM Works, we do have got the possibility to refill this tray in any available free slot inside of the tray unit and then can start the production again. Moving over now from the SIPLACE TX to our SIPLACE SX machines, we now do have got a new passive clinching tool available. So in today's time, of course, miniaturization is still an ongoing trend, but as you can see here on this PCB, also some parts are getting more complex and also getting bigger. So for example, like also odd-shaped components, which needs to be fixed into place via a through-hole technology with subsequent clinching afterwards. Within the SIPLACE SX machines, we now do have got a new adapter plate available with dedicated centering pins and the dedicated clinching pins in order to fold over the lead pins of the dedicated THT components on the bottom side of the PCB itself. This tooling can now be fitted into a standard SMT machines, and depending on the component that needs to be placed, the clinching tool can then move upwards or can stay on the bottom when standard SMT components are being placed. In this way, the SIPLACE SX enables a very flexible way of placing THT components which used to be placed earlier on with special machines or even by hand.
I really like the new tray changer. Johannes, it is slick. So final question to you two. IPC-CFX for the upstream connection. Hi Sam, can you present us a practical use case for that?
Yes, Laszlo, in fact, actually, we're talking about a vertical communication. It means we're providing data from a machine, for example, to a host system. An example for this is the performance monitor. Our performance monitor is a data consumer which can collect machine data from DEC or SIPLACE machines and can collect some KPIs. But what about if it comes to third-party equipment? Here, for example, we can integrate an AOI, for example, from Viscom, which can provide data sticking on the same standard interface we're talking about, which is IPC-CFX. And at the end of the day, next to the utilization and many other KPIs, we have also the yield, which is coming from the AOI based on IPC-CFX.
Perfect. Johannes, is IPC-CFX and IPC-Hermes future-proof?
Of course, Laszlo, they are both future-proof. As you know, the amount of data is increasing at a rapid pace, and data is a valuable resource in each integrated smart factory. So with this increasing amount of data being transferred between machines to machines, it is necessary that they each are able to communicate with each other within the same language, independent of the vendor. And here for standards like IPC-Hermes and IPC-CFX are necessary in order to ensure that always the right data is in the correct place and that the respective data can be stored inside of the Hermes protocol. Therefore, always the functionalities of the protocol itself are always further enhanced to ensure that the board flow management is always being tracked and traced with even more functionalities in the future.
How many members does IPC-Hermes has now?
So there are already more than 60 suppliers supporting the IPC-Hermes standard right now.
Perfect. Thank you both for your expertise. As always, I have also some final recommendations to you. We have a white paper for you to download. You will find the link in our description. Also, if you want to see IPC-Hermes and CFX in action, please book one of our remote demos. For that, you need only to contact your friendly ASMPT account manager, or you click the link below. You will find us at following events in the next future if you want to visit us live. And in our next show, we will describe how to extract the data we are discussing now with an inspection equipment. So both of you, thank you for the chat. Thank you for joining us. Have a nice day and stay open.